Okay, so this is very similar, at least the derivative part is very similar to, I believe it was question number 18 on the 3.3 homework. And there's a separate video for that in the homework help link if you want to look at number 18. But the added step of figuring out where the tangent line of the graph, the tangent line to the graph, where that would be horizontal. I think that's what was throwing most students off. And that idea of a horizontal tangent line was covered back in section 2.5 on the test one material, but it was with a polynomial function. And then I realized you hadn't seen one with a rational function because we ended up not testing the rational inequalities with the sign chart on test one. Since it was going to come up on a later test, we didn't test that. So I realized, oh, you hadn't had that refreshed, that idea of when a fractional amount equals zero. So that's why we're doing it together here. So there's actually two ways to take this derivative. But once you take the derivative, then we're just going to talk about what it means. Like, what do I know about the derivative if it's describing a horizontal tangent line? So there's two parts to the problem. And there's actually two ways to take this derivative. So let's talk about that. So if you want to work with the function the way it's written, so I'm going to rewrite my function here. I have a constant in the numerator and I have a trinomial to the fourth power in the denominator. If you want to use this as is, then you would have to use your quotient rule to find the derivative. Okay, where you would say your top was a constant 1 and your bottom was this trinomial, and then you'd have to do your quotient rule, which you can totally do. And I go through that in that other video example. However, we can bypass the quotient rule if you rewrite the function first. If I rewrite the function, then I can bypass the quotient rule. And that's what I'm going to do here. So I'm going to rewrite my function by doing this. I'm going to relocate that base, happens to be a trinomial, but it's still a base. That base to the fourth power, I'm going to relocate it to the numerator. So there's already an understood 1 up there in the numerator. And I'm just going to relocate that trinomial up to the numerator there. And then that changes my exponent sign from +4 to -4. And once I do that, then I bypass the quotient rule. I can just do power rule with chain rule there. I mean, technically, you could also do the product rule if you wanted to. You could say the first was a constant 1 and the second was this trinomial base, but you could do the product rule if you wanted to, but we don't have to do that because your first term is constant and the derivative of a constant is 0. So we're just going to do power rule. So I'm going to stop right there. Are there any questions on how I rewrote this function so that now it's set up to do my power rule with chain rule? No? Okay, so let's go ahead and do that. So I'm just going to do my f prime notation now because I'm taking a derivative. I drop that exponent down to the front. 1 times -4 is -4. I rewrite my base exactly as it's written. I decrease my exponent by 1. So it becomes a -5. Then I need to tack on the derivative of the base. So let me relocate this real quick so I can have some more room. Here we go. Oh, that didn't work out very well. Give me a second. Okay. So power rule with chain rule. So here we go. So here's the chain rule part. This is the chain rule is where you tack on the derivative of the base. So this is my base, and I need to find, the derivative of the base. So this is my base. Right here, this is my base. And then I'm going to tack on the derivative of the base. Okay, so let's go ahead and do that. Let's clean that up. Okay, so -4, rewrite the base. Okay, now the derivative of the base here, when I look at my base, it's just a polynomial. It's a quadratic trinomial. You just do power rule on each of those. And since the base is just a plain old x for every term. You don't need the chain rule. So this is just x squared. The derivative of x squared is just 2x. Then I have 5x. The derivative of 5x is just 5. And then I have a constant 3, and the derivative of a constant is 0, so I don't need to write it. And since my derivative is a binomial, I'm going to group it in parentheses. So that's my derivative. I don't have to do anything else. That's it. So let me pause there. Show me a status. How are you feeling with that derivative I just found? Okay, so there's a question why I put 2x there. That's because when I took the derivative of my base, so let me come over here. My base looked like this. My base was a trinomial. I'm just going to take the derivative of each term. So I looked at my first term, x squared. So I'm going to use my power rule for that. The power rule says you drop the exponent down to the front. So that would be a 2. I rewrite the base, and then I decrease it by 1. But you don't put that understood 1 exponent because it could look like a prime. And then, okay, so Jocelyn got it. And then Anastasia said, I understand the derivative, but I always want to do more after. Okay, I hear you on that. If you're just asked to find f prime, if that was the only thing they were asking us, you'd be done. You can even put the raw derivative in my math lab. I saw that on my math. I was practicing. I just put the raw derivative, even the raw derivative for the quotient rule, just plugging the pieces into the template for a quotient rule or product rule. It counted it right. If it was only asking you to do f prime. If it put the word simplify in there at all, then you had to clean it up a little bit. Or if it asked you to factor out a GCF or do anything, if it asks you to do anything else, then you have to do some algebra to simplify things to clean them up. You could, if you wanted to, you could reorder this. You could rewrite it with a positive exponent. You could do a whole bunch of things, and my math lab is programmed to do that. So traditionally, what my math lab will do is match the form of this original function. So if the original function has positive exponents only, they would rewrite this base to have a positive exponent, but you don't have to do that. It's good practice, but you don't have to. However, we're asked to find the derivative of the tangent line, right? So we're asked to go this extra step here. Well, not the derivative of the tangent line. We're supposed to find values of x where the tangent line is horizontal. So think about a horizontal line. So this is algebra. Horizontal line. If you have a horizontal line, a flat line like that, the slope is 0. So and the derivative is describing the slope of the tangent line, right? So if they're asking you where the tangent line is horizontal, they want to know where is the derivative equal to 0. So basically what I need to do is ask myself, where would this derivative equal to 0? What would I input into this function so that when I plug in that input everywhere and I do this calculation, the calculation comes out to be 0. That's what it's asking. And it looks really scary and intimidating right now, right? But it's already factored into the 0 product principle, right? Remember when you have an expression and you want to set it equal to 0, you factor it. The 0 product principle says one of the factors has to be 0. So I have 3 factors here. One of these factors has to equal 0. But here's what your brain needs to catch. Your brain needs to catch that this factor right here is not in the numerator. Okay? It's in the denominator. Can the denominator of a fraction ever be 0? Yeah, no, the denominator of you'd never want the denominator of a fraction to be 0. So rewriting it, Anastasia, in this case with a positive exponent is going to be more helpful. So I see there's a question in the chat. Let me rewrite this real quick. So I'm going to rewrite this to say -4. That stays on top. That trinomial is going to move to the denominator and have a positive exponent, and then that binomial is going to stay on the top. Because for a fraction to equal 0, if a fraction is going to equal 0, so for a fraction to equal 0, that means the numerator is equal to 0. A fraction is a numerator over denominator. The numerator equals to 0, but the denominator does not equal 0. The denominator can never be 0, or then it would be undefined, right? So basically all we need to do to solve this is just set this numerator equal to 0. That's it. If you set the numerator equal to 0, then you'll figure out the x factor that would make the derivative equal 0. And there was a question over here. Let me see real quick. Priscilla asks, so we just use the chain rule in this case? Yes. So anytime, well, it doesn't have to be a polynomial, Priscilla. Anytime you have a function in the base and it's being raised to a power. So for example, how do I say this? Yeah, when you look at your function, if the input is going to a base and there's a constant exponent, that's when you know you're going to do power rule. The base might be a pretty polynomial. The base might be a log function. The base might have an exponential in it or something weird. But if the input's going to a base that's being raised to a positive exponent, in this class it's almost always a polynomial, but if the input's going to a base and the base is being raised to a constant exponent, that's how you know to do power rule. Okay, before I actually find the values of x, any other questions on this, what I've done so far? No? Okay, well then let's go ahead and set this equal to 0. I'm going to add a page so I can scroll it up a little bit. Okay, here we go. So let's go ahead and set this equal to 0. So now all we have to do is set the numerator equal to 0 and use our 0 product principle. So either 4 is going to equal 0, but we know that can never happen, so that's out. Or this binomial is going to equal 0. So we just solve that. Subtract the 5, divide by 2. Right? Just solve that like a regular equation. I subtract the 5, I divide by 2. This is the value of x that if I plug it into any form of the derivative, it would create an output of 0. That would mean that tangent line is horizontal there. Okay. So I know that's a lot. I know there's a lot of algebra embedded in there. So make sure that you're coming to office hours or you're reaching out to Madhavi. Any tutor, even in the Learning Lab, can help you with the algebra part and can help you with the calculus part. In the Learning Lab and BrainFuse, they might not be able to help you with the word problems, with like the business part, but they can help you with this basic calculus. Like they would be able to do this problem and help you with it because there's no business part in here. This is pure calculus and algebra. Okay, show me a status so I can see how you're feeling after this doozy of a problem here.
Can you tell me real quick why the -4 would not be 0?
Because -4 is a constant. There's no variable part in it, no variable factor. So no matter what I input into the function, x is what's being inputted into the function. No matter what I input in, that -4 is always just a -4. So there's no way it could be a 0. And the 0 product principle says if two things are multiplying together and the result is a 0, one of the factors had to be a 0. So since -4 can never be the 0, it has to be the other one that's a 0.
Thank you.
Cool.
So our final answer is x equals -5/2.
Yes, and that's because they asked us up here to find the values of x that create a horizontal tangent line. So if I plug this value of x, so if I plug that value of x into any form of the derivative, the raw derivative, the simplified derivative, any of them, it's going to create an output of 0 because the slope of that tangent line would be 0 there. And you can see it on a graph. If you put this function into Desmos, if I had time, I would do that. I would graph it on Desmos and I could like sketch out tangent lines. And at this input, what is that, like 2 point something? I don't know, at -2 points. Anyway, wherever that input is, I would see the tangent line would go horizontal on the graph at that point. Any other questions or comments on This one, oh, sorry, there was a question. Yes, so you could have distributed the -4 inside the binomial and just solved it algebraically, and that would work. Yeah, so her question was, could I have distributed the -4 in there? The answer is yes. Then you would have gotten -8x minus 20. But if you would add 20 divided by -8, and it would still reduce to this exact same fraction. But you could only do that because it was a constant.
That's what I wanted to do first, was factor that 4 in there.
Yeah, and that's totally fine to distribute the 4 in there. You can only do that because it's a constant, because the -4, well, not because it's a constant, sorry. You can only do that because your binomial has an understood exponent of 1 there. If it had been an exponent of 2 or an exponent of 3 or any other exponent, you would not be able to distribute a monomial into the binomial. So I didn't show that because this is a special case where you happen to be able to do it, but it won't always be the case. And Jocelyn asks, if it didn't ask for the values, then that wouldn't even be part of the question. Yeah, so they might have just said like find the value, or they might have just said find the derivative, Jocelyn, or something. It just because they asked us to find where the tangent line of the graph is horizontal. And the reason why they're doing that is on test 3. So we saw it a little bit on test 1 with polynomials. Now we're seeing it with rationals. On test 3 is all about graphing. And let's say I'm graphing a profit. I don't know, I'm making a graph up here with profit. Here my tangent line would be positive, so my profit's increasing, the rate of change is increasing. Here it's like my tangent line would be getting slightly less positive. At the top where your tangent line is 0, where the derivative of that x value, whatever this x value is, that derivative is 0, that means like you've reached the maximum profit. So being able to find a derivative, set it equal to 0, figure out what x is creating that, is going to be like a quick way to find mins and maxes. I know you talked about maximums and minimums in your prerequisite course. We're just going to see that in the context of calculus. We're leading up to that, so they want you to practice that skill a lot before we put it in a word problem. But that's where we're headed with this idea of this horizontal tangent line. And then if the tangent lines are negative, they're going to tell us the profit's decreasing, and we're going to get to read a lot about business situations based on tangent lines. Okay, so we need to go ahead and move on to today's notes. But if you have any other questions on this, watch that video I posted. I think it was number 18 from the 3.3 homework. This is also recorded, so you'll be able to rewatch this.